Hi, this is Jiten Kumar, and today we are going to discuss some basic concepts of chemistry, and topic name is mole concept. So mole concept is very important topic in chemistry. It covers approx 60 to 70% part of chemistry in terms of their numericals and their involvement in other concepts also. Okay, so before going to discuss mole concept, we have to understand what is the meaning of mole. Okay, so mole is simply a term which denotes as a unit. So mole term denoted as a unit. It is similarly if we talk about unit of length, so unit of length measured in kilometer or meter. If we talk about the unit of weight, so unit of weight measured in kilogram and gram. If we talk about the unit of volume, so unit of volume is liter or milliliter. So similarly mole also a unit. Okay, so how we discuss the mole and how it is introduced in chemistry. So if we talk about the atom and molecules, they are extremely small in size and their numbers even in a small amount of any substance, so that will be very large. So we can say that atoms and molecules are extremely small in size and their numbers in even a small amount of any substance is really very large. Okay, so atoms and molecules are extremely small in size, but their number in any substance is very large. Okay, so just as we denote 1 dozen for 12 item, 1 score for 20 item, 1 gross for 144 items, and 1 rim for 500 pages. So we can write just as we denote 1 dozen for 12 items, one score for 20 items. If we talk 1 gross, so 1 gross for 144 items and 1 rim one rem for 500 pages. So one rem contains 500 pages in a bundle. Okay, so these terms are used to represent so many things in a very small term. Similarly, mole also a collective noun which is derived from Latin word mole, which means heap or pile, or we can say this is the collection. Similarly, mole also collective noun which is derived from the Latin word mole. So meaning of which mean a heap or pile. Yeah, we can say this is a collection. And this mole term was introduced by Wilhelm Ostwald. Mole was introduced by Wilhelm Ostwald in 1896. Okay, and this term mole was accepted to provide a simple way of reporting a large number, the massive heap of atoms and molecules. So we can write the unit mole was accepted in 1967 to express the large numbers of atoms and molecules in a sample. Okay, so we can define 1 mole of substance by the comparison of carbon 12 isotope. So definition of mole is, if we write the definition of mole, so 1 mole is the amount of substance that contains as many particles or entities, they may be atoms, molecules, electron, proton, neutrons or other particles, as there are present atoms in exactly 12 gram of the C12 isotope. So we can write definition of 1 mole. So 1 mole is the amount, 1 mole is the amount of a substance that contains as many particles or entities, it may be atoms, molecules, electrons, protons and neutrons, or other particles. As there are atoms in exactly 12 gram of C12 isotope. Okay, so this is the definition of 1 mole. 1 mole is the amount of substance that contains as many as particles or entities as there are atoms in exactly 12 gram of C12 isotope. Means 1 mole of a substance contain as many as particles which is equals to present in 12 gram of C12 isotope. So we can write 1 mole is equals to 12 gram of C12 isotope. Okay, so this is the definition of mole. Next, in order to determine this number, precisely the mass of a carbon-12 atom that was determined by mass spectrometer and found to be equal 1.99 into 10 raised to power minus 23 gram. Okay, so if we determine the mass of carbon-12 atom, so we can write mass of carbon-12 atom by mass spectrometer. So it will be equals to 1.99 into 10 raised to power minus 23 gram. Okay, and as we know that 1 mole of carbon weighs 12 gram according to our definition. So we can write we know that 1 mole of carbon weighs 12 gram so the number of atoms in it equals to, so that will be equals to, so if we have mass of one carbon atom and we have 12 gram of carbons, so we can calculate the number of carbon atoms. So we can write 12 gram per mole C12 atoms and divided by mass of one atom, that will be 1.99 10 raised to power minus 23 gram per C12 atom. Okay, so we can write, so this will cancel out and we will get here 6.022 into 10 raised to power 23 atoms per mole. Okay, means 1 mole of substance contains 6.022 into 10 raised to power 23 atoms. So that number called as Avogadro constant, that is denoted by Na. So value of Na is 6.022 into 10 raised to power 23. Okay, so this is the Avogadro constant. Okay, and if we talk about this calculation, so this calculation done by Jean-Perrin in 1909. So above calculation was done by Jean-Perrin in 1909. Okay, so in this case we have to denote the constant. This will be Perrin constant or Jean constant, which is calculated by Jean-Perrin. But to give the honor of Avogadro, he named it Avogadro constant. Okay, because in 18th century Amedeo Avogadro expressed the idea of that much of value which is equals to Avogadro constant. That's why Jean-Perrin give the honor of Avogadro. So in the honor of Amedeo Avogadro, it is called as Avogadro constant, which we can denote by Na. Okay, so this is the history and definitions of mole. Now come to the next part, calculation of mole, how we can calculate moles. Okay, so we use this way to calculate moles. So next heading will be calculations of mole. Okay, so moles calculation we can done by three ways. First, by given mass, by given volume, and third one by given number. Okay, so if mass is given, we can calculate number of moles. If volume is given, then also we can calculate moles. And if number of particles or number of atoms are given, so we can calculate by the given number. So we can calculate this. If mass is given, so that given mass divided by its atomic mass or molecular mass. Atomic mass or molecular mass. So if mass is given, so divided that mass by the atomic mass or molecular mass, we will get moles. If volume is given, then we have to divide that given volume by 22.4 liter, because 1 mole gases contains 22.4 liter volume at STP. If number is given, then we divided that number by Na, means Avogadro number. So we can divide this Avogadro number, we will get moles. So once we get number of moles, we again calculate mass, volume and number. Okay, so this is the very simple mathematics trick. If we want to calculate mass, so we have to multiply this mole by atomic mass or molecular mass. Atomic mass or molecular mass. If we want to calculate if we want to calculate volume from moles, so we have to multiply number of moles by 22.4 liter. If we want to calculate number by given moles, so we have to multiply that moles by Na. Okay, so this is the simple structure which we can calculate number of moles by given mass, by given volume, by given number. And if we want to again calculate mass, volume and number, we have to just multiply it by their coefficients. Okay, so if we want to calculate number of moles by given mass or weight, so we can write number of moles is equals to given mass or weight, and it will divided by their atomic mass or molecular mass. Okay, if we take an example, if I have 16 gram of oxygen, so calculate the number of moles. So in 16 gram of oxygen, number of moles is equals to, given mass is 16 and oxygen means this is O2, so their molecular mass is 32, so we can write here half mole, or we can write 0.5 mole. Okay, if we want to calculate moles by given volume, so we can write the formula number of moles is equals to given volume, and it is divided by 22.4 liter. So we can take example, if 5.6 liter hydrogen is present, so calculate the number of moles. So we can write number of moles of hydrogen, that will be equals to, given volume is 5.6 liter, which is divided by 22.4, so we will get 1 by 4, or it will be 0.25 mole. Next, we can calculate number of moles by given numbers. Okay, so number of moles is equals to given number, and that given number divided by Avogadro number or Na. Which is equals to 6.022 into 10 raised to power 23. So we can take examples. If 10 raised to power 26 atoms of neon are present in atmosphere, so calculate the number of moles. So we can write number of moles of neon is equals to 10 raised to power 26, which is divided by 6.022 into 10 raised to power 23. So we will get 1 by 6 into 10 raised to power 3 moles of neon. Okay, so in this way we can calculate number of moles. If we take an example to calculate the number of moles, so write down a question. Question is 8 gram of oxygen contains. Okay, so this is the question. Contains first number of moles or we can say total number of moles. Second, total number of molecules. Third, total number of atoms. Fourth one, total number of electrons. Fifth one, volume of gases. Okay, so these are the questions we have to calculate for 8 gram of oxygen. So we can solve this question. So any question based on mole, we have to calculate very first number of moles by the given data. So here we have 8 gram of oxygen. Okay, so oxygen we have to use O2 in natural gases. If he says about the oxygen atom, in that case only we have to take single oxygen, otherwise we have to take O2 in respect with oxygen. Okay, so our first question is number of moles, or we can say total number of moles. So total number of moles will be given mass. So given mass is 8 gram divided by molecular mass. So we can write 8 gram is the given mass and molecular mass is 32. So we will get 1/4 moles of oxygens we have. So second question is total number of molecules. Total number of molecules. So in case of molecules, we have to multiply given moles by Na. Okay, so we have 1/4 moles which is multiplied by Na. So we have Na/4 molecules. Okay, next total number of atoms. So as we know, one molecule of oxygen contains 2 atoms. Okay, so it contains 2 atoms. So we have Na/4 molecules. So we can calculate total number of atoms. Number of molecules into 2. So we have Na/4 molecules and which is multiplied by 2. So we will get Na/2 atoms. Next, fourth question. So fourth question is total number of electrons. Total number of electrons contained by the 8 gram of oxygen. So as we know, one atom of oxygen contains 8 electrons. It contains 8 electrons and 8 protons. So we have the number of atoms and one atom contains 8 electrons. So we can calculate total number of electron. So we can write that is equals to total number of atoms into 8. So we have total number of atoms is Na by 2 and number of electrons is 8. So we will get here 4 Na is the number of electrons. So 4 Na electrons we have. Last question is volume of gases. Question is volume of gas. Okay, so we can calculate volume by the mass. We can calculate volume by the number of moles. So there is a formula given moles multiplied by 22.4 liter, given moles into 22.4 liter. So we have 1/4 moles and this is the 22.4. so we will get 5.6 liter volume of oxygen. So we have 5.6 liter oxygen. So in this way we can calculate number of moles, number of molecules, number of atoms, number of electrons and volume of gases. So this is the very simple way. First, in any question we have to calculate number of moles by given quantity. So by the given quantity we have to calculate number of moles, then we proceed further. Then we have to calculate further calculations. So in this way we can calculate so many things. Okay, thank you.